Hello. So today we're going to be looking at different measurements that you can use for angles. Now there is a myriad, meaning a lot of or many, different ways to measure angles that have been used throughout the centuries, throughout the millennia even, by different civilizations, different parts of the world. But these three have stood the test of time, so to speak, but they're commonly used, especially today in our world, especially when it comes to different fields. In a general sense, in the sense of surveying or doing machining or doing trying to be as exact or approximate as we can be with the angle measurements, and sciences. So these are the three that are used most popularly, and these are probably at least two of them, maybe just one of them you've heard of throughout your lifetime, maybe all three for some of you. So the first one is going to be degrees. We've mentioned that before, even with our definition of our types of angles. Degrees is a general measurement that's used throughout. It's been used for honestly, seemingly forever. A lot of times people may not even realize it, but 360 degrees is there because 1 degree was representative of going one part of a rotation around the sun. So we would have a complete rotation of 360 days. That's why our number of days is so close to 360. And other days were added over years, so we end up with 365, except every leap year. Um, so that's just talk about degrees. Now, sometimes you will hear people call degrees DD or decimal degrees. The reason for that is because that whenever we represent degrees, we use the decimal system to do so. When I say decimal system, I mean based off of tens. We have a ones place, we have a tens place, we have a hundreds place, a thousands place, 10,000, so on and so forth. Or going in the other direction with fractional parts, we end up with our tenths, our hundredths, our thousandths, our 10,000ths, 100,000ths, millionths, and we can keep going either direction. But we can measure our degrees in that same fashion. Now, do remember that a complete rotation is only 360 degrees. So if you were to go past that, you could give a complementary angle or an angle, that's probably actually not the best word, but an angle that is in the same exact position as the other one. So, for example, if we went around 720 degrees, we would be right back where we started. So 0, 360, and 720 are all actually the same angle measurement, but the number is represented in multiple ways. Okay, so anyway, if you see just degrees, think decimal degrees. Or if you're asked to give something in decimal degrees, that means just degrees. So you can leave it with a decimal in the answer, or if you get a whole number, just put it down there. You got your whole number. That's it. Now, the reason for this distinction here with just saying degrees and saying decimal degrees is the emergence of degrees, minutes, seconds, also known as DMS. DMS, degrees, minutes, seconds, DMS. So DMS is another measurement of angles that's based off the first one. So if we were to think about going around a complete rotation, for each angle in that representing one day of the year, well, what about the Earth? The Earth rotates around, right? Okay, within that 24 hours. So if we do the same thing for the Earth, then we can count each part of the rotation as similarly to an hour almost, right? Yes. Now, this analogy will only go so far, but it will help you understand degrees, minutes, seconds. If you think of degrees as how many hours have passed or how many hours of rotation, then there'd be 360 in the whole day. Then if you think of it that way, because the Earth has to rotate completely all the way around itself, this will make this a lot easier to do because it's something that you'll be used to if you think of this as hours. Why is that? Well, because how many minutes are in an hour? That's right, 60. Well, how many minutes will be in 1 degree? 60. Good. How many seconds are in a minute? 60. And how many seconds will be in a minute? 60. So this will all be based off of 60s. Now I've been told several times that the Babylonians came up with this. The reason for that is most likely they love the number 60. they were obsessed with perfect triangles, as they saw it, that were equal on all sides and all the angle measurements were equal. And that would give you an angle measurements of 60 degrees. And so everything, if they could break it up into 60s, they would. When you have a complete rotation, they took 6 triangles, put them together, they had that complete rotation around. That was 360 degrees. When that was just even better, because it was just 60 times a factor of 60, which is 6. And you're like, oh, awesome. Let's just keep doing that. And their whole number system, ours is based off of powers of 10. So we have the decimal system. Theirs was based off of 60, because that's how much they love this number. But anyway, if you can think of that and remember degrees kind of being like hours, then you will remember that it takes 60 seconds to make 1 minute, and it takes 60 minutes to make 1 degree. And we'll, of course, talk more about this when we're converting between the 3 that we have here. Speaking of which, the last one here is radians, mostly used in science when it comes to physics, or finding angle measurements of some kind. You see it a lot in advanced trig courses as well, or in calculus and higher level mathematics. The reason is because of this little Greek letter that we get to use here that actually represents a mathematical number. Many of you probably know what it is, or you've heard of this, and it is called pi. Now, I actually don't know if there's a direct correlation with us calling these pi and the fact that we use pi in order to find out many things about a circle. That would be kind of interesting to look up sometime. But anyway, so we have radians. By the way, that pi is not spelled the same. This is pi. That one would be PIE, which might be another interesting thing. I may have thought of something. Anyway, so radians is defined by the distance traveled around this arc. An arc we'll talk about more later, but it's just the outer part of the circle. So it's how much have you traveled in relation to the angle that you've gone. So how much have you traveled around the circle in relation to the angle that's gone? Well, that's called radians. And this comes from the fact that it's based off the radius of the circle. Because if the radius is larger, then depending on the angle you've gone, you've traveled more. If the angle is smaller, then depending on how far you've gone, the angle is less. If the radius is smaller, the angle would be less. However, that relationship or that proportion would be the same. It would be the same radians regardless, as long as the angle was the same. And because of that, they then can say, oh, well, if I know the angle, I'll automatically know what this proportion is. And if I know what this proportionality constant is, I can find the other two if I know one of them. Or I can find the other one if I know the other. So if I know what the radius is, I can find out what the length around the circle is. If I know what the length around the circle is, I can find the radius. All I have to do is know the angle. And so this proportionality constant they call radians because it's based off the radius. Now, generally speaking, in many math books or even science books, you will see a radian with a pi next to it. The reason is because generally this pi comes up a lot in this answer, in this proportionality constant. And so they divide it out and leave it next to it. So they don't have to keep writing it over and over and over again. So I'm going to leave it at that with one last thing. But just to review, so our different measurements of angles, we have degrees, also what we call decimal degrees. We have degrees, minutes, seconds, which will also be called DMS. And then we have radians. Now, let me show you a relationship between degrees and radians. So the distance around a circle, how many degrees would that be? That would be 360 degrees. Okay. Well, 360 degrees around a circle, if the circle just had a radius of 1, the total distance around the circle would be 2 pi times the radius, which would be 1 in this case. So we would get 2 pi. So in relation to what the radius is, the proportionality constant of the distance around a circle will always be 2 pi. That's the reason why the circumference has 2 pi in this equation. It's actually based off of that. But anyway, so with this, that means we get 360 decimal degrees is equal to 2 pi. Always. And if we keep this ratio, we can reduce that further by saying that, hey, 180 degrees is equal to pi radians. And that will be used when we're converting between units of measurements. So remember, we got decimal degrees. We have our degrees, minutes, seconds, because 60 seconds would be the same as 1 minute. We add that here. This would be 60 minutes, which would make this 360 degrees, which is here. So degrees, minutes, seconds. We have our degree, decimal degrees, and we have our radians. And there is a relationship between all of these based off of that one complete rotation around. So that is measurements of angles, and I will see you soon for converting them.